Hi, I'm Chris Bergh. I'm head chef of a Cambridge, Massachusetts company called DataKitchen. And I guess our purpose for being is to help companies do data ops. Well, yeah, I've had a long career. So I sort of working class kid from Wisconsin, went to the Peace Corps, taught math for 2 years, then went to Columbia, and then did a bunch of years at a project to automate air traffic control with MIT and NASA. And so, I've always been a very technical guy, wrote a lot of code, and did AI back when AI wasn't cool. And then for a bunch of years sort of got into both consumer, internet, and then enterprise software companies and left the technical domain and started to be a manager. And about a dozen years ago, I joined an analytics company that did it was a bootstrap company that did everything that you could think of for kind of healthcare analytics. And so we did data integration and data management on a daily, weekly, monthly basis. We did visualization and charts and graphs. We had data scientists before they were called data scientists. And we even made the mistake of building our entire stack of analytics, all metadata driven, with software. And I was the chief operating officer. And so my life was pretty much structured around kind of three things. One is the guy who founded the company was a very bright, not too technical Harvard Medical School doctor who really knew the domain. And he would go off and talk to customers and have a bright idea and then come back to me as COO and say, well, here, take this bright idea and run with it. And so I'd get people together in a room. I'd have some data scientists and data engineers. We called them ETL engineers back then. And maybe some software engineers. And we'd hash it all out and say, okay, this cool idea is going to take us 2 weeks to do. And I'd walk back into my boss's office and say, oh, it's going to take us 2 weeks, and be very proud. And he would sort of look down his glasses at me and say, wow, Chris, that takes 2 weeks. I thought that should take 2 hours. And I'd feel very embarrassed and sort of walk out of my office and then, kind of get a call on my phone from one of our customers. And they would say, Chris, there's a problem in the data. If you don't fix it, you're out. And I'd have some more gray hair sprout then, and then I'd walk a little farther, and we had a lot of bright people that we hired, and they say, oh, there's this cool open source tool. Can I try it out on our next project? And so my life is kind of making the trains run on time in analytics as COO of a moderately sized kind of technology and consulting company was, how do you deliver analytics in the broadest definition, whether it's data or a model or a visualization? How do you deliver all those things to a business customer fast? And how do you deliver high quality so you don't have errors? And then how do you let your team innovate? And so that was my life for a bunch of years. And the company grew, and then we sold it to a West Coast company called Model N. And I was knocking around to figure out what my next thing would do. And we talked to a couple hundred people and did customer interviews, my co-founders and I, who also worked at the same company. And we realized that a lot of people had the same problem we had, which was, they are there's a new role called a chief data officer or a chief analytic officer, and they sometimes have data engineers and data scientists and people who do data viz underneath them or working with them. And they're kind of they have this sort of duality to them. One is they're getting beat up by their business customers the same way I got beat up by my boss because they're just not going fast enough or the things break. And the other is this sort of great desire for innovation. I was at the Gartner conference for a few weeks, and there was a mess of sort of chief data officer types there. And they really do want to prove their value to the organization because they really do believe that analytics and data has power to actually help organizations make fact-based and reasonable decisions. And so that they're caught with this desire to innovate and this challenge of just going too slow and making the trains run on time. And so the way that we touch the world is we think the idea to innovate really comes from iteration. And so that's where the idea of data ops comes from, and that's where our company, our company is focused on. That's sort of a long answer. Did that answer your question? Yeah, yeah, and it's the tech industry, right? So all these terms, data ops, data engineering, I think of them as a gas. They sort of expand to fill the available space. Like I remember when big data just meant, clusters of parallel machines with dumb storage, and now big data is everything having to do with analytics. And so, I think that's just an aspect of the tech industry I'm not particularly fond of. But we have an idea of what we think data ops is and why it's relevant to people, and we've authored a manifesto. We've talked about it at conferences, and we really do believe that it's a better way for people who are doing data analytics to work, and it's a much more satisfying, much more happier way to live your life, and instead of sort of being browbeaten by business people or frustrated that things are breaking or killing yourself with sort of heroic deeds and then waking up Saturday morning when you should be at soccer with your kids with a panic that something is wrong in the database, and then having to skulk off the soccer field because you just got an email saying it's broke and having to go in your car and fix something. And so it's and I don't know if you can identify with that, but like I'm sort of done with making changes and having things break. It's not a fun way to live. Yeah, and you can identify, right? And so, I think it's that look that my wife gives me is just like, you've been married for a while, and it's like, oh, you're an idiot. And so, and it's harder too, because having been both the person on the keyboard who's done the work and the person who's made the mistakes and the person who's managed those people, I've been fortunate to see both sides of the equation. And I'm a big believer in Deming, this guy who sort of industrial process control, and a lot of the problems I think emanate not from an individual. I mean, almost all the problems don't have to do with an individual screwing up. And sort of yelling at someone or blaming something for a problem is not the right attitude. It's really about the system in which people work. And if that system is right, people can do great work. And yeah, they're going to make errors. And the only error, I think, is if they make errors, that's fine. You just make sure they don't make the same one over and over again. And so loving your errors, iterating and improving, iterating and innovating, I think are what data analytic teams, data engineers, data scientists really need to focus on in order to be successful. Yeah, exactly. And I think, the DevOps kind of goes back to the Agile Manifesto, goes back to total quality management, goes back to this crazy guy Deming, and that sort of idea of loving your errors and trying improving them and automating the testing and automating the deployment is really it's really gone through the software industry. And back when I was a development manager in the early 2000s and late 90s, I thought I was a pretty cool guy if I could get my team to ship software every 3 months. And now if I would try to get a job as a development manager saying I could ship software every 3 months, I wouldn't get a job, right? Because the expectation is that you should be able to ship software every 3 minutes or 3 seconds. And why, the question is, why does that expectation exist in software now? And why doesn't that expectation exist in, at least broadly, in the realm of people who do data and analytics? And that's, because I really do think it should. Yeah, and so, having been a data engineer and hired data engineers, I think of data engineering as sort of a software developerization of what people called DBAs or ETL engineers. And what do I mean by that? So I think a lot of companies have hired people who know how to use tools like Informatica and Talent, and they're very comfortable that this tool is it, and they exist in this sort of very slow but successful waterfall process to deliver things. And I think the idea of data engineering is that it is a way to think of their work more from code than visual designs, more from a agile way of doing things than a waterfall way of doing things. And I think it's actually really good for people out there to think of themselves as data engineers, because I think that is actually the way the field's going. And companies that we talk to don't want to have to put a ticket in a system and then have a 6-month project to update whether it's a data warehouse or a data lake or whatever they call their data infrastructure. It's not operating at the speed at which their businesses or their customers need. And so I think whether it's a data engineer doing the process of data ops, or a data scientist, or whether there's actually going to be a role called a data ops engineer, I think data engineering is really a really important field, and not just something that you should cost minimize and send to India and work from tickets. I actually think that data engineering, given that it's actually the majority of the work in the analytics cycle, is actually hugely valuable. And so I'm happy to see it. If my impression of the term data engineering is really an upskilling or an up statusing of the field, and I think it's just long overdue. Yeah, and I hope I never have to go back to like buying servers and binding your database code to your database and then having to clone it to back it up. And I think those, it's sort of, the job I talked about before to do the analytics, we had hundreds of servers that we had to buy and provision, and where I was it was very difficult to sort of lift your data and your processing from one server to the other, and we had to sort of jump through hoops to figure out how to do that. And so I think the idea of cloud resources, the ephemeralization of resources, the idea of coding to create or shut down resources, containers, all those things are really, they give you the ability to iterate, they give you the ability to deploy quickly, they give you the ability to sort of reproduce what you've done, and they take, that DevOps term, cattle not pets, they take, in some ways, they take that from being sort of a black art, and you've got to have that single point of failure because John over here in the corner knows where all the servers are and all the passwords are, and you can't touch them, to being something easily deployable. So I think the sort of cloud virtualization makes a big deal in how you do it. And the other way I think it makes a big deal is sort of the cutting and pasting of a database. And I think one of the secrets of going fast in analytics is being able to have versions in development that are based on what is in production. And so sometimes you want to do that, have all of your, if your database is reasonable size, tens of terabytes, hundreds of terabytes, sort of cloning it in a Redshift or an EMR and AWS is not an unreasonably slow thing to do. If you've got petascale database, then sort of sampling a subset. But really the idea is, can I have a place where I do my work? That's where I've cut and pasted all the data, cut and pasted all the exact versions and environments that I have, whether it's versions of database or versions of Python libraries or that version of R that I'm using. and then all the code, I'm acting on it. And so I've got my place to do the work. Or likewise with some of our customers, they have variations of what's in production. They'll have production that's got 2,000 people on, and another copy of production that's slightly different that's got 3 people on. And so cutting and pasting of data and infrastructure really is enabled by virtualization. And that was just super hard before, because you'd have to go and talk to your database salesman, who always seemed to be an ex-football player and wanted to take license fees from you, and they were just, I never really enjoyed talking with those types of people. But now, so it's much nicer to like spin stuff up, try it out, shut it down, and follow the sort of principles that were laid out in DevOps applied to data. Again, a long-winded answer. I hope Oh yeah, I just never liked the Oracle salesmen. Man, they were always, I don't know, they always like went to the gym before it, and it's like, oh, you've got to get 4 more CPU licenses to try something out, and like, why is that? I just want to try something out to see if it works, and so that's. Yeah, and I think in a. Oh no, go ahead. Yeah, and I think fundamentally, people who do data engineering think of their work as code, and I think that's the right way to think of it. I think someone who does data science, their work is code, and so whether it has a model or a model that has a bunch of random input parameters, it's still code. And even if you look at a Tableau workbook, you open it up, it's code. Maybe it's XML code, but you can even, there's a bunch of nested if-then-else statements. Now you can embed Python into Tableau. Fundamentally, the thought inversion is that a lot of the tools out there are IDEs from a software developer standpoint. Tableau is an IDE. RStudio is an IDE. Informatica is an IDE, integrated development environment that produces code. And so if you think of your job in data analytics as a code producer, that code has a lot of weight from someone who's managed software teams. And if you grew up in software, you think, I do code. And then there's a whole bunch of thoughts that come after that. It's like, code is complexity, code is communication. Code can create this big hairball that's going to cause me problems later on. And so the culture of how to treat and how to deal with the combinatorial complexity of a code-based environment is sort of, I think a lot of data and analytic teams are a bit of denial of that. And I think the vendors are sort of feeding that into it. The vendors are like, hey, you do it in my system, everything's great. And they all sort of say the same thing, like, oh, you'll be fast, it'll be great. But the reality is it's code and complexity. And so how do you deal with that code and complexity? How do you change it? How do you modify it? And so software's got a lot of really good ideas from the DevOps movement. And also, there is more to it than software does, because data pipelines are these sort of living things, and sort of deploying them, monitoring them, testing them is different. And so also the front end, sort of creating environments for people to work in is different than it's similar but different than the DevOps that most software engineers have. So yeah, I guess I keep talking, but that answers your question. Yeah, and there's different ways to handle it. So one is, if your data is in the tens or hundreds of terabytes, just back it up and back it up to a bucket store like S3 or a file system, and then restore it. And usually the networks and having a full copy of production. If your domain allows the ability to do that with security and sort of personal information, that's one way to do it. And then the other way is to take it and do a sampling or a filtering of that data set if it's too large or there's security concerns. And that could be another sort of process that someone does, create a sampling ETL to give you your test data. And then a third technique is there's companies like Delphix or others that do data virtualization, and then if they allow you to sort of kind of point your database at different data sets. And so in general, I think a lot of people, if you've got tens of terabytes of data, and just copy and paste it because the network can handle it. But yeah, I think for us, it's also it's not a data problem, but you got to have the data. You've got to have a representative hardware software environment that's like production, which means the same tools, the same versions of libraries. You've also got to have a copy or a branch of the code that you're working on, whether that code is SQL code or Informatica code or whatever. You've got to have that in your environment. And then you've got to have sort of a dial that says, I want to run part of the process, all the process. And in order to do that, you've got to also be able to say, I need to test each step of the process. So if I'm going to make a change, I take a copy of what's in production, the data, the code, the scripted environments. I make my own place for it. And then I run, in essence, a set of regression tests to make sure I've got a representative sample. I make a change in something, I add another test, and then I run the whole thing again to make sure I haven't broken anything. And when you have your data environment, having thousands of tests, or think of 20% of your code is test code, whether that's testing as monitoring of production, testing as regression testing, functional testing, system testing, all the same concepts that exist in the software world, then you have a really high confidence that you're not going to get that call on Saturday morning, because the tests will tell you if you've broken anything. And that will also tell you that you're not the hero anymore. And that's also a cultural problem, is that there's a lot of, I think, heroism in tech, where if you are really good at something, you can produce a lot of code and a lot of technical debt, and then you get to be the person who's called in to fix it. And while that can be really emotionally satisfying for a while, it ends up not helping the team as a whole, and then you end up being pulled in if you're the hero, and I've done that role, you end up being pulled in lots of directions, and then you end up quitting. And so it's not as there's a lot of reasons to have a development environment that's representative of production, that has your code, and to do all the work to make these tests, in the broadest term, that allow you to make changes to production and fast enough. And I think testing and data and analytics is an underappreciated field, and it really should be the center of what people do. Oh, is there Dad? I heard that kid. Dad, I'm hungry. Yeah, yeah. And, well, we could talk an hour about this, right? Because we had to build a framework in ours, and so in our software to do that. And so, yeah, because if you think conceptually, you're testing two things, right? You're testing the data, and as the data flows, whether it's streamed in or it's a kill and fill refresh, or it's another set of transactions being poured into your analytic data warehouse, data lake, whatever you call it. That set of processing is you need to monitor that and make sure that the data or the artifacts are all being produced. So for the purpose of having the business people or customers that you're delivering to not find problems when you've delivered it. And so that is, think of that, I think of that as testing, but in reality it's sort of monitoring in some way. And these sort of pipelines that you do, in our view of the world, is that pipelines aren't just data pipelines, they're data pipelines that also have predictive models, that also have visualizations in them. And all those things need to be tested, because someone could have changed them, or some data could have come in from some vendor that's crap and broken something. So that's one aspect of testing, right? Monitoring what's in production live. The second conceptual aspect is that if the work that data engineers and data scientists do are really code, well, then all those ideas that exist in software development of regression testing or testing need to take place. And so how you do those things exactly, and the logic of doing those things and keeping track of the test results is important, because a lot of ways the monitoring of what goes on, think of it as a Toyota factory, your production process where data comes in on the left side, whether it's Python, SQL, pick your language, operates on it, and then there's some R and some predictive modeling, and then there's some visualization. Think of it as a Toyota factory, and each step along the way that it's being transformed and artifacts are being added to the assembly line. And the assembly line is not a line, it's really a directed graph, but that's not important. It's that conceptual idea that you have something, a living process that is manufacturing innovation and value for your customers. And just like Toyota and Deming said, well, let's monitor that, let's get statistics on it, let's not yell at the people who made errors on it, let's give people the ability to pull a chain and stop the assembly line. I think those same ideas of lean manufacturing, statistical process control apply to data and analytics. And so you need to kind of think about what you're doing as a factory, but you also need to think about what you're doing as an innovation pipeline, deploying pipeline. And so those two things are actually really hard to do together. It's sort of as if you've got a Toyota factory where you can have anyone in the factory take a machine out, change it, and put it back in a few seconds. And so that is really the state that you want to have in analytics, and that's a hard state to do, right? It's hard to have the lots of changes, lots of data going by, and lots of innovation going by. And so the quality tests can break up in a lot of different ways. So there is the basic of looking at, did the data I get is what I expected? The row count changes, the looking at sort of the whether it has the right number of columns, whether the data fields are right. Those are tests that you really should have, because you want to have those tests as close to when the data arrives as possible, just like Toyota. And so that way you can kind of, like Toyota does, go back and yell at the manufacturers of the radiator and say, look, you're giving me some defective parts, go fix it. Because oftentimes you get defective data, and sometimes the data engineering team has the choice to say, oh, I can just fix this data, and then I can keep my production process going. And so that can be a good thing to do sometimes, and it can be a bad thing to do sometimes. But you've got to think about how to manage that. And so tests that can tell you that the data is bad before your customer sees it are really important. And so there's a whole lot of tests between statistical process control tests, between the logical tests that you get from your business customer, between what we call historical balancing. We look at what happened previously versus now, and there's a whole art to actually writing good tests. But that idea, I find shocking in a lot of data analytics people, that testing should be 20% of your work, automated test, and that testing shouldn't sit on a shelf somewhere. It should be automated, deployed as part of your process. That's really the idea that we're trying to get across in DataOps. Yeah, yeah, and I just, there's a lot of times you have data warehouse builds that could take hours, right? And a data gets in at the beginning, and then you don't notice it until hours or day later, or, God forbid, in front of your boss or the boss's boss's boss. And so how do you set up a system where people aren't being defensive, where they slow things down because they're afraid to get yelled at, but because their boss's boss's boss will see it, and everyone's locked in this circle of I don't know, fear. And I think what breaks the fear is that you can have provable confidence that what you're going to give to someone, your boss's boss's boss, will work. And the only way to have provable confidence is to build automated tests that you can trust, and run those during development and run those while they're in production, and parameterize them accordingly. Yeah, yeah, exactly right. Yeah, so, smaller, frequent releases are better because they're easier to debug, and they're also easier because then your customers are getting more value quicker, and you can learn from them. Because the whole point of Agile is feedback, is to counter the fact that we're all introverts who do this work, and get these crazy business people and customers to give us feedback to make sure we're making the right choice on the way we implement. And so I think there is this emotional context that I'm trying to get across to people, is that really if you're living in fear of making changes, and you're waiting for the big deploys, and you're kind of hoping things are right, or you've got these like change review boards, or where it's the 3 people who know the whole system are sitting around the table and they're reviewing your code or making sure it doesn't break all these other systems, those things are just, they're just a pain and not fun. And like, if you can get rid of your change review board and really empower the youngest and least knowledgeable member of your team, and have him or her press a button and deploy, and really have confidence that that won't break, then you're on to, you've achieved a great velocity. And so that spirit, I think, needs to, in a lot of companies, isn't there because of fear. And also, I think the intellectual framework of data ops and the idea of data ops really is not present in people in the data and analytics world. And so I'm what I'm trying to do with the company is sort of colonize the mind space of people on data and analytic teams to say, look, data ops is important. Look, this has really changed the way people work in software development. It's changed the way people work in factories and manufacturing. I mean, I grew up in the 80s in Wisconsin and saw the Japanese imports lose 50,000 jobs in Milwaukee because of the fact that they can make cars better and cheaper by following Deming. And so there are a set of ideas that are, I think, whether you call them Agile or Lean or TQM, really need to apply to what we do in data and analytics. Yeah, so one thing is, if you want to love your errors, yeah, I hear you. We have a thing called Tornado Report, which allows you to track by data source where the errors were, and so we also include the data engineers or the data scientists as part of that. And so in order to understand where the errors occur in production, you need to sort of find out where they come from and look at the hotspots. That's one area, sort of error reporting. The other part is sort of SLAs. Are you delivering on time? We have metrics around, think of sort of an equivalent. There's not really a code coverage metric that exists in analytics, but we have a sort of a ratios of tests to steps in the process, so you can tell sort of, is this work being done well tested. So it's about errors, it's about deployment, it's about kind of ratios of code to tests that we enable with our software. But it's also something that we're continuing to evaluate and improve upon ourselves, because I think and I think the more modern DevOps tools actually are better at that, because they've been doing it a while. So there's some inspiration and ideas that we're going to take from those. Yeah, we don't have sort of a magic box to do that, right? So what we think is that what people should do, if you think of all the work in analytics as a directed graph, and people should be able to run parts of that graph in their development environment, they should have a basket of parameters where they can say, okay, I want to run this test based on a small input data or a big input data, so that my tests can run fast and quickly. And also they should try to have their work be done where I'm working on one piece, and my one piece is separate from other pieces, and I can run it over and over and over again and make sure I do the sort of design, see the results, judge the tests, and iterate and improve. Because another thing that's happening in data engineering and data science is it's becoming much more of a team sport, instead of the individual hero who's doing his or her coding from data to value to the sexiest job of the 21st century, where I do everything in analytics. It's a team of people who are doing things, and that the teams have to decompose their processes into steps. And so I think like in software development, you should be able to choose which tests that you do, and have some tests be functional tests, some tests be kind of the equivalent of unit tests, some be system tests, and be able to turn those on and off based on what you do. Yeah, and I wish that more people in the data and analytics world had that thought, and they were far enough in thinking of automated testing to break them up into types and when you run them and how to optimally be able to allocate the tasks based on what your work pattern is. Most people I encounter, the idea of automated regression of your data analysis suite is foreign. And so most companies will have a few tests that run at the beginning because some data engineer or ETL engineer put them in, and then they have largely manual processes to validate, or they're just winging it. And there's somebody who's grabbing some data from somewhere, they're doing some transformation, they look at it, it looks good, and then they push it out to the exec team. And so there's a lack of process discipline for most people who do data and analytics. And I think that's also a challenge in the DataOps movement, because kind of more fun to not have to think about your process and just do some stuff, throw it together. Hey, it looks good, and that, I think, is one of the reasons why there's a lot of rework, there's a lot of data errors, there's a lot of mistrust in analytics. A lot of data and analytics projects are failing because of that, because people are just, I mean, the biggest challenge in analytics, in my mind, is getting business people to trust the data. And what that means is actually make data-driven decisions as opposed to gut-driven decisions. Because if you're running a major brand that's spending millions of dollars, or you're a CEO, you're like, you've got a lot of reasons why not to trust the data. You've got your gut, you've got your intuition, you've got what your friends say, what you heard here, some major trends, and all that is in the mix of making a business decision, and data is not the only thing that impacts it. And so, we've from a data and analytics field, we've got, I think, a while to go, and getting people who are not in the field to start trusting and making data-driven decisions. And I think that's a cultural change, and I think people are getting more and more on board, and there's more and more analytics as part of life. And when I sort of started doing data and analytics in 2005 or 6 full times, I had to explain to people what it was. And I had to tell them it's charts and graphs. And they're like, oh, okay, you do charts and graphs. So I think now you can't go through an airport and not see it. So there's a cultural change that's coming in analytics, and the seat of the pants sort of thing. But really, those advanced things that you're talking about are advanced in data and analytics. And I just wish they weren't. Because to really just do automated testing. Just do that and write them now. You don't need to buy any software. Just make some automated tests. If you're a data engineer, make automated tests and put them in whatever harness you have, and then your life's going to be better. That's the one thing you should remember from this podcast. And do them now. Yeah, and from someone, if you look at, I'm a big business man or woman. I'm looking at my charts and graphs, trying to, decide whether to spend some money or save some money or invest or do whatever. And so you have no concept of all the steps that go underneath it. And the weird discontinuities that happen in technical systems, right? Like changing something could take a minute, and changing another thing could take 2 months. And for your perspective, it's all like, I don't know, it's all like a black magic beans underneath, and people and things are moving around. And so, but I used to sort of bridle against those people demanding to make changes. And so I used to think, oh, they just don't understand technology, they don't understand this discontinuity. But I realized that that's not unreasonable. It's not unreasonable for them to expect fast changes. It's not unreasonable for them to expect really high quality. And also, it's not unreasonable for the people who are in doing the work to expect to be able to try some stuff out and innovate and try all those great open source libraries or new tools out there. That's not unreasonable. So everyone in this idea of, I want something fast, I want to innovate something, I don't want to have any errors or problems, they're all perfectly reasonable. And so instead of, I went through my own process of sort of pushing back and on all those in some ways, quality, features, time, innovation, and saying you can't have it all. And so I spent 8 or 9 years building a system that tried to have it all if you do it all in metadata, it'll all work. And I got like 80-90% there, and there's always like a bag on the end that didn't work. And so I'm not a believer in those types of systems anymore. But if you apply these ideas that have been done from manufacturing, done from software development, you apply the principles that we wrote about in the DataOps Manifesto, I think you can actually do those things. It takes a while. It's a cultural change as well as some tooling change, but I think you can go fast and not break things and innovate. Well, I think the way that we think about it is that there's a couple of aspects to what people need to do. One is that there's this idea of a pipeline, which is a graph. And in that pipeline are all the pieces that you do in analytics, from grabbing data from somewhere, transforming it, putting it in a database, doing models on it, visualizing it. So you need a graph that covers all that. And we do that. And there's other tools that actually do graphs like that. I mean, there's plenty of ETL tools. There's plenty of open source tools like like Airflow or Luigi. That's one part of the problem. Another part of the problem is when you run that graph, you've got to be able to test each point. And so you need a test framework sort of embedded in that part of it. You need to get test history. That's one thing also that we do. So that we call those, since we're DataKitchen, we call those recipes and tests, and we use a bunch of cheesy food metaphors. So you've done that. I got a data pipeline that's running. I can monitor it. I can keep track of test results. Cool. And it integrates with all the other tools that you need to have, because you may have Informatica, you may have Tableau. You need to work and containerize that, and we've got some open source stuff that allows you to abstract some of that stuff away. So that's one part. The other part is you got to do what you called CI and CD, which is deploying. And there's tools like that. There's Jenkins. There's tools that Amazon has or Azure has to be able to take that pipeline and all its code and put it through a process to deploy in production. And so that's similar to what those tools do. And then the other part is that you've got to help people with building these environments to do their work. And so the dev box, like in our own software development, our dev box setup is, it's sort of bunches of Python and shell scripts that we use to set up our dev box. And they're great, but they're for our software engineers. And so what you need is, if you're going to expect people to go fast, you need some way for a data engineer or a data scientist or even someone doing Tableau to kind of spin up some resources where they can make a playground and then be able to run tests and push a button. And so all that stuff is that you could theoretically you probably could piece it all together from different tools, but then the surface of interaction for your users would be half a dozen different tools and scripting languages. And for software engineers, it's probably fine because they like all the tools. But we've sort of put that together in a package and have a set of best practices that if you use the tool, you can then start doing data ops. And so for us, though, since we're a small company, we're bootstrapped, we're trying to pay our employees salaries, selling software and helping people through that transformation is what we're trying to do. But from a guy in the industry for a while, our purpose is to get people to do data ops. And yeah, you can use your software, but you can, if you want to start doing it, you don't need to buy software. You can start applying the principles now, just in Python or SQL or however you're doing your work. Yeah, let's move on. I guess I don't like these things to be too much of a commercial, because I think most people just, they turn off. And so I'd rather keep it at what is data ops, what are the principles, how do you do it, rather than the DataKitchen's commercial. Yeah, some are good. Some tools are good data ops citizens, and some aren't. So databases generally are, right? Because you can pour data in them, you can run them. Sometimes you can run them in a container, sometimes you can't. But you can pour data in, you can pour the code in, and you sort of have them in the same kind of virtual environment. You get the same results. Other tools are a little bit more challenging. Some of the ETL tools, they really want to own the relationship. They want to, they don't play very well with version control, because they either store their work in binaries or store them in XML files. And so you got to kind of treat them like blobs instead of being able to kind of, branch and merge them. Tableau, for instance, is not a very good data ops citizen. We had to do a lot of work just to be able to pull a Tableau workbook out, run some tests on it, and then push it back in. And a lot of what they've tried to optimize kind of on the manual process, and they've got nice UI, but the whole point of doing this is that you should be able to script a change. Everything should be done with scripts, and so that's where the industry is on two challenges. One is that bigger companies are trying to own the entire footprint of analytics, and so they bigger companies who like the big Hadoop vendors, they're like everything and under the sun. And you just do it in our platform, you're fine. And then even tools like Tableau, they're sort of expanding out into data prep, expanding out into data science. The data science vendors are expanding out into data visualization. And so I just reject that idea that there's sort of one boot, one tool on your neck. It's a multi-tool world. And those tools need to be able to be scriptable, deployable. You need to be able to shove in the work that you've created in them and be able to test the results and then pull it back out. Because fundamentally, if analytics is code, then all code should be in tools of version control like Git. Whether it's a predictive model or whether it's Tableau workbook or SQL or Python, all that stuff should be in Git. And because it's a central place. And again, big companies, by and large, don't do this. They'll have some code in file systems. Sometimes it'll be in Git, or sometimes they'll put it in Informatica's store somewhere in some database somewhere. And so I think the industry needs to realize there's some work that they need to do to stop this belief that, and this has been going on for a long time, that you should do everything in my environment. And that's just not the way the world works. And there's so many existing systems, and there's so many tool chains that need to be coordinated. And so I find that just a challenge in that we try to integrate with a lot of tools, and some are good and some aren't. And so that's one of the things I think the industry can do is get better at being good data ops citizens. Yeah, and like we just all we wanted to do, we have a Tableau container that we wrote, and that's part of our analytic container spec. And so in order to get, all I wanted to do was take a Tableau workbook, have it connect to a data source, and then make a change to it, and then deploy it back and get some test results out. It's like, it seems like Tableau has a REST API. It also has a command line API, but neither of those was able to do it. So I had to actually use Selenium and talk to their UI, and then the only way the UI is I could get the actual data out. The REST API I could only get an image out. And so fundamentally, think of these things as black boxes. If work is code, I want to take my Tableau workbook and put it in source code. And then I want to make a change, and then I want to be able to make sure I haven't broken anything. So I've got to stick it in a system that's representative of production, get some test data out, and then check to see if it's right. I mean, that seems to me, how else are you going to have your Saturday mornings free unless you're able to do that in an automated way? And so, yeah, we had to jump through some hoops to do it. And Tableau's a big company. I think Looker's a bit better in the BI space. Some of the data engineering tools, ETL tools, are a differing degree. But how to be a good citizen in a DevOps, data ops world, I think, is important for vendors. And just stop getting over this idea that your sales VP is going to, because they have your one product, you're going to replace every other product in the $100 billion analytic industry. That other idea is also just makes me nauseous as a guy who trying to sell our product and stands around at trade shows once a month. It's not the way the world is, and we live in a diverse tool world, and tool chains and tools matter, and people love their tools, and the idea of the sort of big boot on people's neck where everyone's going to use their tool is just silly. I guess I think from my perspective, from a career standpoint, I really like data and analytics for a lot of reasons. One is that there's a lot more women in going into data analytics, and so if you go to in Boston, there's going to be the Open Data Science Conference. There's a lot more women. It's a very diverse field. It has a lot of different people with different skills, and I think in some ways the idea of the value of data analytics is kind of lifting and separating from IT or software development to be kind of its own thing and its own culture. And so I think that's really good, and I really like the data and analytics field and all the different subsets, whether you call yourself a data engineer or a data scientist, or whether you're a data artiste who does Tableau. I think all those things are it's a really big, growing, diverse field, and I think it does have challenges with Agile and applying the Agile principles and doing data ops are one of the biggest areas I see as the problem. But there's also just a whole lot of opportunity for people to kind of grow in this career. And I'm heartened to see billboards. Like I was driving through Hartford 6 months ago and I saw a billboard for a master's in data science. And those things didn't even exist 2 years ago. And like we've been hiring, and we are hiring. If you're a data engineer looking for a job, go to DataKitchen.com. We're hiring a bunch of data engineers, but there's also a lot of graduate programs where people are actually learning to be data engineers. And I think that's a really, it's a great career. And so I think the transformation of data engineering from, it's the lunch pail guy who does the data work in the back room, and to a skilled professional who delivers a high value to the organization. I think that's ongoing. But I really do, I'm a big believer in data engineering, and I'm a believer that they should be paid well, that they have as much value as the cool kids in the block now, or a data scientist, or even more so. And I think it's a great career for anyone to get into, and there's just a lot of jobs out there. So if you're looking to make some money and have an impact, it's a good career to get into. Nope. No, I think I've kind of said my piece. I don't know if there's anything. I kind of cover that, don't you think, in other ways? Okay, yeah, and thanks for the opportunity. And so the next step is you're going to do some editing, and then